Hi, if you need to sketch a quadratic curve, there are maybe 4 or 5 basic types that you need to worry about. And here's the first one. This one is called the parent function of all quadratic curves. And this is what it looks like. Okay, just like this, passes through the origin, right? I'm trying to take care that that is actually a curve. So it mustn't be sharp. Yeah, still not got it. Well, that looks better. You know what I'm talking about. So yeah, that's what it is. This is your y-axis and this is your x-axis. So every curve that has the equation y equals to ax squared, a being positive, will look like this. It doesn't matter if a is a fraction, proper or improper, or a whole number. Really doesn't matter. That is what it's going to look like. Okay, what of if a were negative? What of if a were negative? What you have will just be a flip in the x-axis. So it's going to be a translation, okay? A reflection in the x-axis, basically. So it's going to be a reflection in the x-axis, and this is what it's going to look like. So if you've done anything like transformations before, this is a reflection in the x-axis, okay? So this one represents every y equals to ax squared, where a is negative. Okay, of course, when a is 0, the function will not exist. I mean, this function is a 0 function, right? Okay, so this is the first case. Let's look at the second case, right? For the second case, say you have y equals to x squared plus 1. What happens is this. There is a skip 1 unit on the y-axis. So what do you call it? A translation, yeah? So it skips 1 unit on the y-axis. So this is 1. So it simply lifts up 1 unit on the y-axis. It's as simple as that. Okay? What of if we had y equals to negative x squared plus 1? Well, remember that y equals to negative x squared goes this way. This is y equals to negative x squared. But because there's a plus 1, you just lift it up 1 more unit that way so that it crosses y equals to 1. You literally just lift it up. Well, I've not drawn that very well. But hopefully you can see what I'm trying to achieve. Okay, so let me just clean this off and then write that. So you have y equals to negative x squared plus 1. Obviously, you're going to have to state what you have on the x-axis there, which are called the roots, and the y-axis here. We already know this one is 1. That's easy. Okay, you can also already pick it out here. Okay, but what will the roots be? Right, you can rewrite this obviously as 1 minus x squared, and this would be a difference of 2 squares because 1 is a square, x is a square. So you have 1 minus x, 1 plus x. That's how you resolve difference of 2 squares. Which means at this point where y is 0, we know y will be 0 here. Y is always 0 on the x-axis, okay? If we make y 0 here, we get our x to be 1 or minus 1. So this part here is minus 1, and this part here is 1. Okay, this is the second scenario, all right? When there is a vertical movement, a translation, okay? Either up or down. This is the kind you see, all right? So for instance, if you had, say, y equals 2x squared plus 5, simply draw your graph, lift it up 5 units. So at that point will be 5. That's all. And if it's minus 5, if instead of plus 5, what you had was minus 5, you drop it down 5 units. Okay, so that will be negative 5. Just remember that you then have to find these 2 points by making y 0 and then solve it for x. Okay, now we go to the third scenario. For the third scenario, say instead of having y equals to x squared plus 2, or let's say plus 3, instead of that, you have y equals to x plus 3 all squared. If this is what you have, here's what you do, okay? This plus 3 here represents a horizontal shift. Remember, this represents a vertical shift. But this one, because it's inside the brackets, all right, represents a horizontal shift, but it's a negative horizontal shift. It's a negative horizontal shift. So what do you have? Instead of having this, you then have a shift horizontally towards the negative. So it's going to sit at minus 3 because it's moved 3 units. And it looks exactly like that. Well, it's a sketch, so not exactly. The only thing that is left is you have to make x 0, because at that point x is always 0. And then figure out what y will be. If x is 0, y then will be 3 squared, because this will be 0 plus 3 all squared. So that's 3 squared, which will be 9. So y will be 9. And you're done. Let's look at the next scenario. What if what you had was y equals to x minus 3 all squared? Obviously, from the origin, you move this way. Okay, you move that way. All right, so this represents a positive movement. Okay. And to get the y-intercept, you simply make x 0. Again, you get 9. And that is that. Now we go to the next scenario. Okay, and now to the big ones. This time around, let's look at y equals say x squared plus 6x plus 18. My advice would be that you write this in the form of y equals to a into x plus, say, h, then plus k. Because with this one, you can easily pick out the vertex, okay? You can look at the vertex. If you like the maximum or minimum, it means the same thing. Yeah, also you can look at the roots of the equation, which is also the x-intercept if you like. I think there are 2, so x-intercepts, and then you can pick out the y-intercept also. Okay, what else are we going to need? That seems basically it. So yeah, to be able to write in this form, please check a video that I will link up just right now. If I haven't already linked it, just check it and try to write it. And try to learn how to write quadratic equations in that form. Okay, but if we are going to do it now, best way to do it is to look at this first of all. So you have y equals to x squared plus 6x, and if we have to add something to make it a perfect square, we will halve 6 and square it. That gives us 3 squared. Okay, because that wasn't there before, I'm going to take it out so that this essentially cancels, and then I have 18 left, so I say plus 18. this trinomial here is a square. So that's x plus 3 all squared. Then I have plus 9. Good. And yeah, that's what we need. Now, the parent function for this is y equals to x squared. So that's the first thing we draw. It's not because we need to draw it. It's just because I need to use that to explain. That is y equals to x squared. Now for x plus 3, this one is a negative shift. So it's going to move 3 units towards the left. So let me do that. I move it 3 units towards the left. Let's say that is 3 right there. Okay, in that case, I'm going to write this as negative 3. All right, and then plus 9 means you move upwards 9 units. You move upwards 9 units. So if you move this, I'm just going to, move it upwards 9 units. Okay. So in that case now, this one here will be 9, okay? And this one is negative 3. All right. And, we just need to maybe figure out what this is. It's obvious that your graph has no roots. So for this particular one, we don't have anything there, but we should be able to find the y-intercept. And at that point, we need to make x 0. So we know x is 0. On the y-axis, if we make x 0 here, we should have that part to be 18. Isn't it? That part should be 18. Okay, so it's a bit awkward the way I've drawn my graph. Probably better to take this a little bit upwards. Let's see. Yeah. And maybe this one, take it out entirely. Yeah, okay. So that's what we have. This is my y-axis, x-axis, if you like. Yeah. Probably should leave this up a bit because 9 seems so far away from 18. That will make more sense. Okay, so that is our y equals to x plus 3 all squared plus 9. Okay, if you want to see how that is truly graphed, you can always use a graph plotter online, and you'll be able to do that. Let's take another example. And for this example, this says y equals negative x minus 3 all squared plus 9. Okay, remember y equals to x squared. That's the first one we sketch. Then we look at y equals to negative x squared. The reason is because of this minus. Then next we look at negative y equals negative x minus 3 all squared. And then the last bit, we look at y equals negative x minus 3 all squared plus 9. Okay, and then we can look out for the roots. We look out for the y-intercept, that's 5. Look out for the roots, that is make y 0. And so for x, okay? And then we look out for the y-intercept, that is easy. We make x 0. Okay, and then we find the value of y. Okay, and look, basically I think that will be done because we can easily find the minimum or maximum from this. I think it's going to be a maximum because I think it's a negative graph, isn't it? So it's going to be a maximum. Okay, let's get cracking. Y equals to x squared. We know that will just come down this way and then go back up. That's a bit wobbly. I'm not going to be worried at all about it. So that is that one. The minus here reflects the graph in the x-axis, so it's this way. Okay, this one right here represents a positive shift 3 units. So yeah, let's shift it 3 units right there. Okay, we don't need to worry about this point where it crosses yet because we are moving it up. So this place will be 3 isn't it? Now we need to move it up 9 units. Okay, a couple of things we need because if we move it up, that point there will be 3,9. We need to find out where the graph crosses the y-axis. So let's make x0. If we do that, we make x0 there, we will get 0. Okay, when x is 0, y is 0. I hope you can see it. Let's make x0 here. If we do that, then we have minus 3 squared is 9, so minus 9 plus 9. That is 0. Okay, so when x is 0, y is 0, we know that this must have crossed the y-axis at 0 there. Okay, I think it's making sense because, you know, it's just going to go up most likely this way. Just go up that way and then come back down. Okay, probably haven't drawn it well. Let me cut this out. Yeah, okay, sorry. All right. So what would this point be? That's what I think I need to consider now. And that point here, y is 0. So make y 0. If we make y 0 here, what happens? We have 0 equals to minus x minus 3 whole squared plus 9. Okay, if I take this to the other side, I have x minus 3 whole squared equals to 9. Take square root, I have x minus 3 equals to plus or minus root 9, which is 3. And then I have x to be equal to 6 or 0. So, which means that this point here will be 6, will be x equals to 6. I think I need to move this backwards a little bit so that it makes sense. So that's x equals to 6 right there. Okay, and you know, job is done. This one is 0. Because your exam questions will specify usually that you should label your axis. So we've labeled our x-axis. This one also is our y-axis, and that's also labeled. And we have added the maximum right there. That's the maximum. Okay, so that's how you sketch a quadratic graph. I hope this helps. I'm going to be stopping this video here. See you next time. Bye.